Today we're going to be discussing lead and how it prevails in our environment and the effects of long-term exposure. What is lead? Lead is a heavy, ductile, and malleable chemical element which has many real-world applications. Though it is a very useful metal and has been used for a variety of purposes in the past, recent studies have shown that lead can have a poisonous and rather dangerous effect on the human body. Lead is the heaviest member of the carbon family. Unlike the lighter members of the carbon group, lead tends to be found in the +2 oxidation state. Lead and lead oxides can react with acids and bases and commonly form covalent bonds. Lead does not conduct electricity or sound well, and in addition, it can be obtained in high abundance at a low cost. So as you can imagine, it is favorable in many applications, such as construction, batteries, and piping. Relative to other metals, lead has a high density, low melting point, notable ductility, and the ability to oxidize rapidly. Such properties make lead a useful resource for day-to-day applications. For our presentation, we will introduce some elemental reactions that involve lead and the consequences of lead exposure in biological processes. Oxidation of lead. The only common example of the +2 oxidation state in carbon chemistry occurs in carbon monoxide. According to the image above, carbon monoxide is a strong reducing agent because it is easily oxidized to carbon dioxide, where the oxidation state is more thermodynamically stable at +4. With lead, the situation is reversed. This time, the lead-2 oxidation state is more stable, and there is a strong tendency for lead-4 compounds to react to give lead-2 compounds. The lead-4 chloride, for example, decomposes at room temperature to give lead-2 chloride and chlorine gas. Lead compounds can be separated into two major groups: organic lead compounds and inorganic lead compounds. Organic lead compounds are most often combined with carbon and hydrogen. These compounds are used to make leaded gasoline, tetraethyl lead, and tetramethyl lead. Inorganic lead compounds, such as lead oxide and lead chloride, are combinations of lead with other elements. This is the type of lead that is found in leaded paints. So how exactly does lead react in our environment? And more specifically, how does it react in our pipes? Iron dissolves very slowly in water, and in addition, it does not tarnish or rust quickly. However, if it is placed under hot, acidic environments, the lead will react rapidly and will therefore tarnish much faster. This becomes a major problem when using lead in water pipes. Nearly all homes built before the 1980s still have lead solder connecting copper pipes. It has been found that after some time, lead can actually dissolve into the water that we drink and use daily. In fact, due to a lack of proper filtration, this has become a major issue in many parts of the world. As you will see, proper chemical treatment is vital.
An example of improper water filtration is the Flint water crisis, which began in 2014. The Flint River became the main source of drinking water for the city of Flint, Michigan. Unfortunately, due to lack of proper water treatment, more than 100,000 residents may have been exposed to high levels of lead in their drinking water. This caused for a federal state of emergency, where Flint residents were told to use only bottled or filtered water for drinking, cooking, cleaning, and bathing. Although their water quality has improved much today, residents are still told to continue using only filtered or bottled water until all of the lead pipes are fully replaced, which may not be until 2020. As shown in the diagram above, effective chemistry is thoroughly understood to remove lead from the water. In the first image, the water is flowing through a corroded pipe that has lead and other harmful ions present due to the breakdown of the chlorine disinfectant. Upon the addition of the phosphate corrosion inhibitor, it reacts and uptakes the lead compounds in the water that were being oxidized in this chemical reaction. As a result, the water is safer to be consumed. Lead impacts many biological processes. The shape of proteins can be altered, resulting in a loss of function due to the fact that lead interferes with proteins that cause the genes to be turned on or off by displacing other metals. Continuing research demonstrates certain molecules bind to lead. Some crucial molecules that have been found to be affected by lead are the production of heme, which can lead to anemia, sperm production, which can cause infertility, and blood pressure regulation that can result in developmental delays in children and high blood pressure in adults. Lastly, Lead displaces calcium in the reactions that transmit electrical impulses in the brain, which ultimately diminishes one's ability to think or even recall information. A recent study conducted in Mexico City has shown that the majority of the lead found in breast milk is sourced from maternal bone and diet. The movement of lead from bone to milk continues for up to 6 months after birth. Exposures to lead-contaminated breast milk during infancy can lead to an early onset accumulation of lead in developing bones. However, all levels of lead detected in the breast milk of participants in the study were lower than the EPA's maximum contamination level for lead in tap water. Infant formula, an alternative to breast milk, is often prepared using tap water. With this in mind, it can be concluded that infants are exposed to less lead when drinking breast milk than when drinking formula. Additionally, the fetal blood-brain barrier is less resistant to lead during gestation. Lead is 6 times more likely to cross the fetal blood-brain barrier than the mature blood-brain barrier. Lead competes with calcium in the body, and that creates an issue for the calcium-dependent reactions that occur in the body, specifically with the development of the nervous system and the neuron connections dependent on dendritic pruning.
Although lead quickly became widespread for its many practical uses, in the late 19th century it was recognized as poisonous for humans. And since then, many of its applications have been ruled out. Research shows that lead is a neurotoxin that accumulates in the soft tissues and bones, damaging the nervous system and causing brain disorders, and specifically in mammals, blood disorders. As you can imagine, this became an alarming discovery. So how can we treat lead poisoning? EDTA, or ethylene diamine tetraacetate, which is a chelating agent that is capable of bonding to metal ions at more than one position. It can bond at 6 positions. As seen in the image above, it interacts with the lone pairs on the nitrogens and the oxygens of the alcohol functional group, and it forms a 1-to-1 complex with the cations. In our body, when calcium 2+ forms a complex with EDTA, it can be used as an effective treatment for lead poisoning. When the EDTA and calcium complex is injected into the human body, calcium is displaced by the lead in order to form a more stable lead EDTA complex and is then secreted in the urine. In this reaction, EDTA acts as a scavenger to find the metal ions and pick them up to excrete them. There are a few preventative measures that can be taken in order to eliminate lead consumptions from contaminated water. The first one is using only cold water to drink and cook. Also, you can use a lead capturing water filter. While lead has become a major asset in several fields, it is important to be aware of the effects that lead can have on the human body. Although we cannot see it, chemical reactions are constantly occurring and can have a detrimental impact if it is not monitored properly and handled with caution. Lead oxidizes in the water pipes, leading to contaminated drinking water that, when consumed in abundance, can lead to lead poisoning. That, although can be treated with EDTA, still has an everlasting impact on the human body. Thank you so much for listening to our presentation. I hope that you're able to take away the importance of biochemical reactions in our everyday life.